Given a stem and leaf diagram of the heights of 17 plants measured correct to the nearest centimetre, and asked to find the median and interquartile range. So the simplest way to do this, let's look for the middle one, is going to be to do 17 plus 1 over 2. That tells us it's in the 9th position. So I'm just going to count on 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this isn't 5, it's 65 because we're given the key down here. So the median is 65. You could write median, or I'm going to write Q2. Then for the interquartile range, what we tend to do here, like the simplest way, is once we found the median, okay, and it's just the middle, just ignore it, and then find the median of the lower half. So now I've got 8 values, so it's going to be halfway between the 4th and the 5th value. 59 and 63 is going to be 61. So Q1 is equal to 61. And then for the upper quartile, it's the median of the upper half. 1, 2, 3. So we're looking between 75 and 77. It's going to be 76. And therefore, the interquartile range is the difference between these. Q3 minus Q1 is 76 minus 61. It's 15. Now, to be fair, you can actually get these from your calculator because we're going to need that for the median, the mean, and the standard deviation anyway. It is good to see how you can quickly do it by hand as well. Okay, so let's go to stats mode, one variable, and get the frequency table up. If you don't have the frequency bit, then go to setup. Of course, I'm assuming you've got the same calculator as me here. If not, you have to try and find it. And then it's going to be in stats mode, and make sure you turn the frequency on. Then we can start typing them in. Okay, make sure you're using the full number, so 55, 57, 59. Now I can either write 59 again, or I can just change the frequency to 2. Just make sure you're being careful as you do it. So we've got 3 lots of 65. And then it's going to be, oh, sorry, 2 lots, 69. Okay, and finally 99. Brilliant. Go to one variable calculation, and this is what I mean by, see, Q1 and Q3 are given, and the median is given there. Okay, if you did want to do it that way, you could do it. If you sort of read the whole question and saw, right, I just need to put it all on my calculator, you get there straight away. So the mean, meanwhile, is 69. Okay, and like it's only 2 marks, so basically get a mark for each one, so we don't need to show any work in. And then the standard deviation is sigma x, it's 10.499. Which I'll round to 10.5. And then finally, state one advantage of using the median rather than the mean as a measure of average for these heights. So the mean incorporates every single value, and that's great, but sometimes there's problems with it because if you have extreme values, then it can massively shift up the mean. And that is potentially, well, that is what's happened here. Okay, this is not like way out, but it would be an outlier. So that 99 is going to affect the mean and increase it, whereas the median's not affected by it. So that's what I wrote. I just say median is less, I think let's say less affected by the extreme value than the mean. So yeah, something along those lines, and that's why, yeah, that's an advantage.